Okay, so today it's a review because there's a cumulative test tomorrow on the two easiest tests you've had this entire year. Seriously, in a row, I've never had such high grades. Average of an A. Now again, an average of an A on this test. That's awesome. So now the cumulative. Well, we probably don't need to talk about the test we just did yesterday. If you want to get a review on that because it was your weakness, then go watch the review video for that test. What this is going to be more is a review of that other stuff, linear programming. Now the equation writing part is in both. So you're already good at writing equations, I know, because I just tested you yesterday. But the equations had a twist. They were always like, but at most 25 dogs or whatever. Okay, so let's try to write a couple equations that involve like at most or at least. Okay, so let's make it dogs and cats. And we're going to make D for dogs and C for cats. All right, and here's my statement. You write the right inequality equation. It's actually just called an inequality, not an equation, but write the inequality. I have at least 5 times as many dogs as cats. Be careful. It's so easy to do this backwards by accident. I have at least 5 times as many dogs as cats. Maybe I take care of animals. I'm like running a little, business where I take care of people's animals while they go on trips. That's actually a pretty good business. They pay you a fair amount of money. It's like 30 bucks a day, 40 bucks a day. And let's say that you can take care of like as many as 5 animals. Let's say that you're making 30 bucks a day times 5 animals. It's 150 bucks a day. What? That's a pretty good job. Like if you had to go to Taco Bell and work enough hours to get 150 bucks, you'd be there a long time. So anyway, and then all you got to do is basically make sure that the dogs and cats don't kill each other because, they come back and like, where's Fluffy? Well, I don't exactly know, but Butch, the Rottweiler, looks a little heavier than he used to be. Anyway, all right, so I'd start with dogs and cats and say equals, but they aren't equal. If I said there's 5 times as many, I said at least, but that's important, but we'll deal with that at the end. 5 times as many dogs as cats, the common mistake answer is this. Did you do that? That's wrong. If you didn't do that, awesome, you remembered that. It's actually this, because we should make up numbers that are like this. 50 to 10, wouldn't that be about 5 times as many dogs as cats? Then you go stick those numbers in and see if they work. This is a really important part, because then you can know if you did it right. 50, 5 times 10, 50, hey, it's working. This will also work for helping me figure out the at least part. At least 5 times as many. Now I'm going to change my number to different, not 50. Because to make the example, to exemplify at least 5 times as many, I got to go over that. So like 51. Now I can tell by putting in my numbers which way to put the sign. Dog 51, cat 10, and now I can tell which side to put the sign. The alligator wants to eat the bigger one. If you're going to do your pet care business, don't adopt alligators. Don't hold on to the alligator and the dogs at the same time. So, dogs greater than or equal to 5 cats. Raise your hand if you had that one right. Awesome. Then let's not belabor that point much more. Writing the equations as inequalities then can be graphed, and that would look something like this. Everybody sketch this, please. Make one line that's fairly steep. Make one line that's not as steep. And then we will label these. This is going to be on the red one, y equals negative 3x plus 8. And then we'll do the black one, y equals negative 2x plus 7. Now I know I didn't graph those perfectly, but they're generally in the right places. So there's 3 spots that are important. And I know a lot of you are seeing this one, duh, that's the obvious one that just kind of stands out. But how are there 3 spots that are important? Let me give you an example. Either we're going to be shading on these lines above them or below them, or maybe one's above and one's below, and it would give us totally different answers for each one. I want you to shade the right part, and you can erase it in, like really easy with your iPads to be able to erase it again in a second. But try the one where we're under the red line and above the black line. Where's the feasible region if we're under the red and above the black? So here's shading under the red and above the black. Did you get this little area right there? And how many of you knew enough to cut it off at 0? Because you would, because we use a real world constraint that if this was dogs and this was cats, you can't have negative cats. Really grouchy cats don't count as negative cats. Okay, so you can't have C that's less than 0. So we would say those equations, if I want to make them with x's and y's, this of course would be x and this would be y. Y has to be bigger than or equal to 0. Always. Okay, now we aren't going to do any with you where it could be negative. So you need to include these constraints, otherwise the graph theoretically would go like this forever, and we don't want that. So, and x has to be greater than or equal to 0 also. That'll keep the cats or chickens or whatever's down, graph down on the x positive. All right, now I erase this because we're going to make a different feasible region. What if you shade above both of them? If they both had greater than signs, and you'd shade above both of them. Where would the feasible region be now? If we shade above both, as in greater thans. If it had to be above both, and our common sense constraints were still in there, do you get that that would be the feasible region? Now, would you please circle the 3 vertices of the feasible region? Because one of those is going to give us our maximum or minimum. And I can tell which one it is. Can you? Think about it. We're either maximizing or minimizing, and I can tell just by looking at this graph whether these 3 points, here, here, and here, a lot of you got suckered into picking that point on the test. Why was a point like that not okay? Yeah, it's not, yeah, it fails one of the tests. It's not above the black line. Another way to say it, it's not in the feasible region. Okay. The corners of the feasible region will be the answers. It's either this, this, or this are my answers. How can you tell, I can tell, if this is a minimizing or maximizing problem? My feasible region has no maximum. It just keeps going up, 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 up. There's no limit to it. It's sort of like the idea of if you found something really cool that you could make. Okay, you were amazing at making these little bracelets or whatever. There was virtually unlimited demand for them because you only sold them for like $5. And you could sell as many as you could possibly make. That's kind of like that. They have unlimited profit potential. In the real world, there's probably a limit. Not everybody in the world is going to buy your bracelet or whatever, but there are people that have problems because they can't make enough of what they sell. Like right now, Tesla. Tesla has a lot of demand for their cars. They're selling a $35,000 electric car that are very, very, very popular. And they just can't make enough. Like they want to sell a ton of them, and a ton of people have ordered them. They've even prepaid for them, like paid a bunch of money ahead of time just to get in line to have one. And they can't make them fast enough. So they actually... the owner of the company, Mr. Musk, Elon Musk, a billionaire, sleeps overnight at his factory trying to get it to go faster because they can't make enough. They have so much demand for their car. I mean, it's a good problem to have, but still, if you can't make them, then you can't sell them. So, all right, so anyway, we have, in this case, a minimizing problem. Do companies ever want to minimize their profit? No, but they want to minimize their what? Costs. So if their costs for making this car get too high, do you get how they might sell 1 million of them or 1 billion of them and make no money? If their costs are too high, you know what I mean? You're selling them for $35,000. If they cost you $35,000 to make, then you make no money. So you got to keep your costs down. All right. So this is minimizing a cost function. I'm going to give you the info you need. You write me the cost function. If our x costs 5, and again, that could be 5,000, it could be 5 million, it all depends on the scale of your business. But our x costs us 5, and our y costs us 3, then what's the profit function? Profit is, sorry, not profit, my bad. We're not maximizing profit. We are minimizing costs. So what's our cost function? Then, once you find these 3 corners, let's say one of them's 1, 6, the other one's 1, 4, and then 0, 5, or whatever. You'll get the costs for each and then find the one that's the lowest. All right. By now you should have the cost function if you know what's going on. It would be 5x plus 3y. Raise your hand if you had that one right. Okay, good. Now the hard part, which is finding where those 3 points are. This one's not that hard. If I were you, the way I would do it is by graphing both of them and seeing where they cross. But do that in a minute. I want to talk through how you do the other ones because they're more tricky. This point is particularly special because it's the easy one to solve because it's the y-intercept. Can you just look at this and tell me what the y-intercept is? Yeah, it's 8. Done. I know that spot. If you wanted to, you could do it this way. X equals 0 there because you're on the y-axis. So x equals 0. If you put in a little x equals 0, you'd put a 0 here, and y must be 8. See? That's how you can find that kind. But this kind is tougher because nobody ever just has a snappy way of finding the x-intercept of that. But if you know this definition, the x-intercept is where, fill in the sentence. Y equals 0, you can stick in a 0 right here. This line is y equals 0. The x-axis is y equals 0. So you see where those two cross. You can do it with a calculator if you really want to, or you can just solve a simple little equation here. 0 equals negative 2x plus 7. Then I would use the calculator to find this third one, because I could do it with algebra, but I'd like you to know how to use the calculator to do it. Because on the test, some of them don't solve with algebra really nice, but you can use your calculator to do second calculate. What's the last command? Intersect. Intersect. You're looking for where they intersect. All right. Use your calculator to find the 3 spots, then see which of them gives you the lowest cost. I will pause for a moment while you try this last part. Okay. We have figured out one of the 3 already. That spot there was a y-intercept of 8, so it was 0, 8. This, you're trying to use your calculator to find that. And this one, you're solving this little equation to find this one right here. (3.5, 0) is correct. I heard people saying it, and you're right. 7 halves is the same as 3.5. And then, do yourself a favor. I'm not going to make everybody show me that you can do this, but you better know how to find where 2 lines intersect with the calculator. If you get lost on that, come up and ask me during work time. Okay? Who's got it? Where did they intersect, those 2 lines? Okay, this is scaring me. I only have like 2 people. Okay, there's a lot of people. He's just being shy. What do you say, Mr. B? Where did they? No, you don't have to show me. Just tell me what you got. 1, 5. Raise your hand if you got 1, 5. You are correct. Now, I know the way I drew my picture is off a little bit, but that's okay. 1, 5 was the right answer for where they crossed. So then I got 3 vertices. Here, here, and here. I put them into my cost function, which is here. The 0, 8 gives me a $24 cost. Maybe again, this is $24,000. And that might not be a bad thing if you're selling the cars for $35,000, okay? All right, 1, 5 should have given you 5 times the 1, and 3 times the 5 is 15, and 5 makes 20. If they can use this process and only cost them $20,000 per car, awesome. And last, this guy, 3.5, I think it came to 17 point something. 17.5 And if that's in thousands, 17.5 thousand. All right. So moral of story, that was the best way. That had our least costs. And could it be, in this case, that we are going to do zero of something? Yeah. Maybe Apple did something like this when they started figuring out, should we keep selling this product? And they decided, no, let's stop selling iPods. Remember the iPod? Okay. Because, why did they stop selling them? Well, because really, actually, everyone they sold was probably then somebody who would have bought an iPhone, but was like, well, I don't really need the iPhone. I can just get an iPod and it'll work fine. And so they were actually costing themselves money by selling them. Because if you offered them, some people who would have maybe bought an iPhone say, screw it, I won't buy the iPhone. I'll just have an iPod. It'll be fine. And they made less money than if they would have just not sold them, because other people would have bought their phone instead. So anyway, there are times when the right answer for a company is stop selling that. You're not making enough money. You're actually rating from sales of something else that would have sold, you would have made more money. It's like at the school store, if they sell, these 10-cent suckers or whatever that are like really pop, like 25-cent suckers, apparently is an aficionado. Maybe if they had just only offered $1 items that were better items, and people would say, well, if there were suckers available, I'm buying the suckers. They're not going to make as much. As if they sold $1 items and they sold less of them even, they could probably still make more money. I'm not saying they should stop selling suckers. I'm just saying, and that's probably what's happening, is they probably make half their money on the stupid suckers in the window. So, hey, you do what works. So, and I know they're trying to make money. In this case, it's not like they're going to, the mom who runs the store is driving a new Mercedes now. They're doing it for the school. So if it makes any money at all, it's just going to support other little programs and stuff. So, all right. Maybe they lose money on this product and they make money on that product, and in the end they break even or something. So, all right. So your homework for tonight is a review of this kind of stuff. I wanted to hit the high points and you have a lot of time to work now still. So I am giving you an unusual assignment tonight, and that is, there is a review, and instead of saying to do all of it, I don't really think you all need all of it. So what I want you to do is half of it, but you decide what half. So in other words, if you only need to practice the old stuff, do that. If you want to do a couple of the new and 3 of the old or whatever, just do half of the problems that are there. I'm trusting you to decide for you which half would be the smarter half to do. Okay, so do half of the review, whichever part you felt is best, and that's your only assignment for tonight.